Next up, last but not least, is Chris van Bael with leveraging infrastructure as code for testing, automation, and security. And to say a few words about Chris, he has more than 20 years of experience in software testing. He has worked on various projects, including embedded system, end-to-end testing for entire airports even. Chris has been given training in software testing for 10 years. In 2017, he has founded his own company, TestUQA, to provide training and help organizations to improve their testing and test automation. So huge applause to Chris, everyone.
Thank you. Okay. Thank you for coming to the graveyard shift, as they say, last one. Okay, anybody ever worked with infrastructure as code before? Few people. Yeah, if you have any questions or whatever during the talk, please do. Let's make it a bit interactive. Otherwise, we are finished in 20 minutes. Maybe that's also a good thing. I don't know. But how you depends on how you see it. Yeah, you talked a bit already about most of my first slide. Thank you. So, yeah, I founded Tesuka 7 years ago. I focus a bit on test automation, test improvement, security testing, and coaching and training. I'm accredited for a whole lot of ISTQB trainings and some others. And in 2 years ago, or last year, in fact, I started a bit with infrastructure as code. My current project, I'm a test architect for a company or an organization that does gas and electricity towards your home, let's say. And they have used infrastructure as code for their environments. And as a test architect, I'm responsible for our test environments, of course. So I'm also setting up infrastructure as code there. So I'm not an expert in it, I have to confess. It's just what I learned the past 2 years, let's say, about infrastructure as code and how it can help you in testing and what's good about it and sometimes also what's not so good about it. So we'll look a bit at what's infrastructure as code with some examples, the benefits, the drawbacks, and then questions. But again, feel free to ask them during the talk also. So infrastructure as code, what is it? It's a process of managing and provisioning computer data center resources through machine-readable definition files, rather than physical hardware configuration or interactive configuration tools. So we're not gonna install ourselves a Windows server or whatever. We're gonna make a file that defines that server, and then it will be provisioned for us in the cloud, Azure or Amazon, or maybe another cloud provider that you want to use. It's really dependent on the cloud, of course. Can't do that on a computer, an actual computer, let's say. So it's in the cloud, and we use then those providers to help us make those servers. So we were using it mostly for our own test servers. We were using Tricentis Tosca. Does anybody use that as test automation tool? One, two, a few people, not that many, okay. So it's Windows based, so we need to have a Windows server to be able to use that. It's a bit of a drawback sometimes also, but okay. And every time you need to install it, it's quite some work sometimes, especially in our organization. We have to change ports and everything to be able to install it. And you want to test it out. So you want to test the new version of Tosca, check if all the scripts that we have made still work with the new version. So we build a new server. Yeah, I could ask for a new server and then they make it. And then I try to install Tosca, run all the tests. And then when I go to production with a new version of Tosca, probably things will break because small differences. So now I can build a server completely with that infrastructure as code, and it's completely the same, exactly the same as the one that will be in production. So that's the big benefit here. So some tools, you have Terraform, for example. We are using that. It allows you to define a server, let's say, and networking and everything on both Azure and Amazon clouds. Pulumi, I haven't used that, but it's an open source similar tool that does the same. Puppet allows you to do configuration management and a whole lot of other things. Vagrant also is a very heavily used tool. And Ansible, you can use it then to install things in that server. So you can build a server, for example, with Terraform, that's what we do. And with Ansible, we can install the tools we need in that server. We can also run Windows updates if you want that. You want to be in control. You don't just say, install every Windows update always. You can do that, of course, if you want. But you might also want to first check them again on another server if they work. And if they work okay, then you can say, okay, install these and these Windows updates automatically in my machines, just by changing a code file. Is this readable or no? Can the lights be changed a bit? Is it now readable? Okay, so yeah, infrastructure as code, so I do have to show some code, I think, in a talk then about that. So that's why here is some code. This is from a Terraform file. It's common.tf, so it's the code that is common to all my servers in that specific environment, let's say. And I'll walk you through a little bit on what it does. So at the top, you see a section on Vault generic secret. So HashiCorp Vault is a tool to store secrets in and to get them reliably with code out of that and in a safe way. So that's the path to where all the secrets are stored. So immediately users are provisioned on that server, etc. With the right password, so you can use them further in other scripts also. Then we make a resource group. Yeah, that's then typically Azure. You have to make a resource group and some other things. You also see a lot of var.dot things in this file that points to a different file, a variables file, where the things are typically defined as, what is the, as variable stack number, for example, is then 147. So that's just easy, yeah, put it in one place and then you can easily change it everywhere. A network security group you can make, that's also something you need in Azure. And then a subnet, we can specify the IP address there. Okay, nice. And we can also define a storage account where our hard drives will be stored, for example. So that's the common stuff. You see a lot of tags here everywhere. Tags can be used for many things, but it's mostly for other tools that it's used. Just like, yeah, on a website or whatever, you can also tag something. In Jira, you can tag something. It's just for your reference purposes. For us, that is used, for example, for accounting. If you're on a stack number, that is then used to make sure that the right team gets the bill for all those servers running in the cloud. Those kind of things, also for reporting. Also, if things are not up to date and they should be updated according to the security people, then you get a mail, hey, you're on this stack, you're the owner of this stack, so do something about it. And then, for example, a specific server that we can build. It's a bit smaller, I think, but okay. We define a virtual machine. We can say which size it should have. So if you look it up at Microsoft, in Azure you can find a D4S V3 is a 4-core 16 gigabyte server, for example, with a certain speed. Again, lots of tags here. So as I mentioned, power schedules can be set, when it should be on, when it should be off. That's all automated. So for example, servers that I don't use that much, for example, for performance testing, unfortunately, we don't do sufficient performance testing. So those servers for Neoload are typically off. But we turn them on every Thursday to make sure updates can get installed. And yeah, okay, thank you. So to make sure the servers are up and running on a Thursday, we typically Microsoft releases patches on Tuesday. So on Thursday, it's safe to be able to install them. They're there probably then. So on Thursday, our servers are updated. And then there's other tooling like Rapid7. Does anybody know Rapid7? Yeah, a few people, but Rapid7 is a sort of a scanner. So you install a small executable on your server, and then it can check a lot of things, Datadog also, check a lot of things on your server if they're running or not, etc., and which versions they have, and then that gets reported, and again, those tags come into play there to pinpoint it to the right team, etc. So a lot of those tags. The OS profile, again, here we use that vault to set the right things, the password, the username, etc. Yeah, the boot diagnostics, you need a hard drive for that. Then the storage. So here also we define that we want Windows 2019 data center. We should upgrade it to 24, but okay. So that's the baseline we have. Then we define, oh, sorry, wrong thingy. So we define the storage, OS disk, and some other things. And that allows us to build a server. So in fact, a few other things still needed, yeah. A network interface. A computer is nothing without a network, of course, these days, especially a server. So we give it a network interface, we set the IP address, static. We also give this computer a public IP, that's also doable here, to make sure that, yeah, Tosca, our company name, works outside also if we want to use it. And we can add an extra disk because typically Azure machines come with 2 disks. You get that with that node, but we want an extra disk in case something gets wiped because those are not sure to stay running, let's say those 2 disks. So an extra disk for long-time storage. And that's it. So with like around 150 lines of code, we're able to create a specific VM. And if I want to run it in this, so this one is TSQ, so that's the SUKA then, A from acceptance environment. So if you want to run it in a test environment, I just change all the TSQ AZs to TSQ TZs, and I have a new server. If I want to add another server, I change all the app 1s to apps 2s, and I have another server. And within half an hour, I commit it. My colleague approves the commit, the merge, and then within half an hour, there's a new server running. So that's quite easy, of course. But it does still take half an hour. So it's not something that you can do for your test automation purposes, that you dynamically create a new server at the start of your test. I think that would take too long for most people. Maybe for a performance test that will take 2 or 3 hours, maybe that's okay. But for a typical automated test, I don't think that's useful. You better probably use then Docker containers or start and stop this server that you can also make with code. Yeah. For the networking, we also have some code, of course. So instead of people changing network ports, because that's also some things I encountered a lot in the past, that we make it running in test environment and then we notice, oh, a network port should be open to some other system. Somebody changes it in the Windows GUI or whatever, or on the command line, and then we don't know what we did anymore, and then we go to production and we have exactly the same problem again. Here we keep track of what we do by doing it in a code file and then rolling it out. So, and then we can see, okay, you did this in the test environment, you can easily do that again in the production environment, for example. So yeah, the rules here, we define ingress, so incoming traffic that can go from our acceptance environment to our services environment. Now for Tosca, you have a server and typically you have some agents running the test actually. And the agents are in the services domain and the server for us is in the acceptance domain. So yeah, we need to open the ports, and Tosca is based on remote desktop protocol, so RDP. We need to open the ports, the RDP ports from acceptance to services, for example, for that. And another thing is outgoing traffic. Yeah, Tosca is a commercial tool, so it should get a license somewhere, and that's on these IP addresses. And of course, you have to open that for HTTPS traffic. Yeah? Any questions so far or remarks? No? Okay. So that I explained, and that's also something. And for updates, so this is an Ansible script. Here it's just, yeah, it defines
To update the servers, install all updates and reboot as many times as needed. This is a very simple script, of course, so just start, do everything. Every update is good enough to install, so we do that. And then if necessary, you can reboot. So that's quite easy. But of course, Ansible scripts can be much larger. You can create files, you can copy files, also again from Git or wherever, copy them into your server, change port numbers, etc. Everything you can script, you can, on your server, you can script it with Ansible and then do things on your server. Yeah, so, benefits. It's consistent and reproducible. So everything we do is in code. There's a version history, it's in Git. There's a version history and everything. I can look back on what I do 2 years ago on my servers. I can easily find that. Yeah, you have all the benefits of having everything under version control. And you can reproduce it in different environments, in different times. If my server crashes and it's completely gone or it's hacked or whatever, I can build a new server within half an hour. Maybe configuring it, yeah, again, if you have done all of that also in Ansible, installing the software, configuring it correctly, etc. Might be a lot of work to do that in Ansible, but if you can have done that, again, that's also running, and just the time it takes to do it exactly, how long it will take. So that can be half an hour, can be longer, depends on the software you're using there. Efficiency and speed. Yeah, as I mentioned, it's just a click of the button, or you can even put it in a pipeline if needed. You can just create a new server and install all the software that you need. Easy. Scalability and flexible. You can easily make new servers, etc. I have some examples also, by the way. Yeah. So I can create a new test server to test the new Tosca version, for example. Test it fully through in that environment, and then I can make an acceptance server where I do exactly the same things. And the server is exactly the same. And if I scripted the installer also via Ansible, I can just run it on acceptance also, and I have exactly the same installation. Efficiency and speed. Yeah, for example, we were doing a performance test. We were testing a Mendix application. Anybody using Mendix? Again, not too many people here, okay. So Mendix, the communication between front-end and back-end is quite complex. Normally in a performance test you check what's going over the wire and you look for your variables in there. If I would log in, my name, Chris van Bael, would be somewhere in the HTTP traffic, and I would change that by user 1, user 2, user 3 during the performance test. But with Mendix, that's quite complicated. You can't almost find back anything in there. So you have to test Mendix, in fact, for a performance test also on the GUI. Some tools allow that. I think next door somewhere, somebody is also talking about that. Very interesting, I think, but yeah, I have to be here, of course. And it's in Polish, so I wouldn't understand anything about it. Sorry. So yeah, Neoload can test that, so we were running a Neoload test, and of course, yeah, you can't run hundreds of users in a graphical way on one machine. So you can do that easily for HTTP protocol, but not for a graphical performance test. So they said, hey, we need 10 extra load generators. Can you build those? Yes, of course. I just took the script in Windows Explorer, I copied it 10 times, and then in the scripts I just did search and replace with Notepad++, and in 5 minutes I changed that, committed that, and in half an hour I had 10 extra servers. Easy. Shut down the servers, you don't need them anymore, just delete the files, commit it, servers are gone. So it's that easy, of course. So that's, yeah, efficiency and speed. Scalability and flexibility. Also during the test, we saw that, hey, even with those 10 performance load generators, we could use some more CPU power. So, okay, let's go back to the script, and then somewhere, you saw it there, the standard D3, SV3 or something like that. Can you just change it to the next tier or a heavier tier with 32 gigabytes of RAM, and commit it. And yeah, again, 10 minutes later, your server has now double the RAM, etc. So quite easy to do that. Version control, yeah, as I mentioned, I can look back in Git and see all the changes made over time. Especially for the network rules, that's very interesting to see that, to know what has changed, what is still relevant now. Because yeah, the tools you install, like Tosca Server or whatever, they also change in time. Network ports are not needed anymore, extra network ports are needed. You can easily check that, and ports that are not needed anymore, remove them from the rules, and they're gone. And yeah, you have less of a security issue then, of course. Other benefits, yeah, reduced risk. So it's code, you can review it. It's not something you do at the last moment and you change it quickly and then you forget it for the production server also to do it, or somebody does it on production but nobody knows that the person did that. Here we have code. You can apply the 4 eyes or even the 6 eyes principle. So for example, for building a server, my colleague also has to approve the merge request, of course. For making firewall changes, my colleague and somebody from security also has to check the firewall changes. So we're sure that no strange things are done there. It's more stable, of course. You can replicate across configurations, across multiple environments. Cost effective. You can turn down machines when you want, when you don't need them anymore, instead of letting them running, because it's so much work to build a new server. It's not much work once you have the code, of course. And it provides collaboration and transparency. Yeah, multiple people can look at the code. You can learn from each other. You can learn from the code what was done exactly. So that's quite easy to learn, in fact. And it's not very difficult coding, as you could say. It's just some easy scripts. There's no loops, if then else's or whatever in there. It's just configuration files, in fact. Maybe in Ansible, there's some looping maybe if you need that. Some drawbacks, of course. Nothing comes for free. It's a new technology to learn. As testers, we need to learn more and more. In the old days, you could just be a functional tester and have a nice career. Now you need to learn to program, you need to learn Git, you need to learn infrastructure as code and other things. So it's all extra things to learn. Some people like that, some people don't. I like it, of course, but yeah. It's a large initial investment, of course, to set up that whole framework. You have to get to know Azure, how it works, or Amazon, or another cloud provider, how to create machines in that. You have to learn the Terraform and set that up also, how it will work for you. So in our organization, we have a team dedicated, cloud services team, that really builds all those things. And we just create the Terraform configuration files and the Ansible scripts for our own stack. But they provide the stuff for all the different teams. Yeah, you need good processes. Yeah, of course, you need to have version control, otherwise it's useless. You need to do reviews, monitoring, logging, etc. But that's, yeah, the basics, I would say. And it's easy to create new infrastructure and maybe a bit too easy also. So it's somebody can just create extra servers and then forget about it and then they keep on running. That costs a lot of money in the cloud, of course. So make sure that you turn them off also or delete them when you don't need them anymore. And security. On the one hand, it's very good for security because you can check everything that's done. You can start from a secure baseline. Somebody should make that baseline. For us, it's that secure cloud services team. They make a baseline of a Windows server, and we use that. But of course, yeah, it's also still possible to do things wrong. And then you might have security issues, of course. You need other tools. You might want to check some sort of static analysis of that code that you've written to build those servers. Otherwise, you will find out, of course, once you try to build them. But okay, maybe you want that sooner. You also want to learn how much it costs. So you might need some other tools also to check that. Yeah, and another drawback might be that it's too slow. Building those servers, I mean. So a Docker is much quicker to spin up or whatever. You can do that even for unit testing. But a Docker doesn't always allow a Windows machine or a Windows GUI even. So that might not be possible there. But then you can go to this, to infrastructure as code. But I'm not saying you have to do everything with infrastructure as code. Still a lot of things can be done as containers, which might be much more easy to use or much more flexible and faster to spin up and down. So yeah, I think that's a bit my presentation. Any questions?
Okay, thank you, Chris. Let me dim up a bit, or maybe enlighten us. Any questions from you guys?
Thanks for the presentation, Chris. Regarding the tools, which one do you have more experience? Like you maybe could recommend, like to get started with infrastructure testing?
Yeah, I can't really recommend one tool over the other because I only use Terraform and Ansible.
Okay.
So it's, yeah. So I like that. It's easy to use. The scripts are not difficult to write, but I don't know how it is for the other tools. Yeah.
Any more questions?
Yeah, thanks for the presentation. So you showed the slide wherein the VM was created, but probably I missed or you did not show that how that VM will be turned down after the use.
Well, the VM will keep on running until I delete the code. Or I change the power schedule to, yeah, you will not be able to see it again, but yeah. Where is the power schedule? Yeah, it's not really readable, but here is power schedule. So again, that's defined in that variables file where all the common stuff is stored. So there I can say it's just a cron job. I can turn it always on or always off, or I can give it a cron time frame, or similar to cron, not exactly the same, but turn on Thursdays from 9 till 16 hours. Then yeah, it's running during that time, and then the Ansible script can run automatically or a little bit later. And then the tooling to check if all the updates have been installed, Rapid7, etc., can do their checks because they also need some time. So I should keep it at least for 6 hours on every Thursday, let's say.
Okay, any more questions?
Thanks, Chris. It was something completely new to me, so thanks for inviting me to a brand new world. From a managerial point of view, how do you manage the cost? Because I can see in large organizations with multiple development teams, if a lot of teams are using this, you can have loads of servers that you're unaware of. So both configuration control, cost control, process control, purchase orders, how do you manage that?
Yeah, purchase orders, typically with the cloud, they encourage you to make new servers, so you don't have to first sign a purchase order or whatever. Typically at the end of the month, you get from them a billing from the servers that you used. And with the tag numbers, we can assign it to each team and say, hey, you're responsible for that stack, so you get the bill. And yeah, people also check for that. You can also, yeah, that's just based on cloud. You can easily check how much it was running, how much CPU it was using during that month, etc. If it is oversized or not. That's all the things that typically the cloud providers provide you, or you can query it somewhere. But again, that's that services cloud team that does that. You can, yeah, make some reporting based on their APIs or GUIs to see how much is it used and yeah, whatever, and the costs. Yeah.
Okay, any additional questions?
Maybe I don't catch everything, but is the solution part of the continuous integration pipeline? So
no,
it's not yet.
You can, of course, it's code. You can generate code also, of course. I can create Python code or whatever, or PowerShell, or Java code to create the Terraform files. But as I mentioned, it's not as fast as making a Docker, for example. So we use it typically for our test servers that we use for our tooling. So for Tosca, for test automation and the agents, and for performance testing, for NeoLoad, also for the controller and the load generators.
Yeah, but I imagine that this Terraform scripts could be run at the first, then the test itself against these servers, and then we close down the servers.
That could be, but it takes up half an hour or so
Too long
to
time.
create the
Okay.
server in Azure.
Yeah, understand.
So for a performance test, maybe that's doable if it's 3 hours or if you run it for a whole day. But for a typical automated test, I think that's too long.
Okay, thanks.
Depends a bit on what you do, of course.
Okay, any other questions? If not, then I would maybe have one additional. I saw that you had configured the Vision AI, and I think that this is one of the newest additions to the setup. Are you using it, or is it just for the sake of that this is the new implementation and you wanted to have it configured?
Yeah, it's just to make sure that people can use it, but we don't recommend it. For the people that don't know Vision AI, instead of going on a web page to using XPath or HTML IDs or whatever to find elements on the web page or the tools, the Windows applications or whatever you're using, with Vision AI you can give it a picture, you can even take a screenshot and then import that in Tosca and say you have to click on this button, it looks like this. And then there's some AI stuff going on, and it recognizes the button, even if it changes a little bit, can do that. But it's not that fast, of course. It's not that, we are not fans of that, let's say. I'm not saying it's bad, but in my opinion, it's better if you work on a web page just to find the elements with IDs or a good XPath or whatever, those kind of things. For me, that's more reliable and faster than, all those things.
Okay, thanks. Okay, guys, so I guess that's it for today. Well, first of all, a huge applause to Chris.